Hello, this is going to be a lesson on adding and subtracting rationals. So this would be add and subtract rationals. I want to start it out with an example. Very simple, because the denominators are going to be the same. If you remember, rationals are like f fractions. And one thing about adding and subtracting fractions is you need to make sure the denominator is the same. So if we do this example right here, which is x squared Alright, here's the example. X squared divided by x plus 7 minus 49x plus 7. If we notice, the denominators are the same, so that means I can write the two fraction as 1 under the same denominator, x plus 7. That's our least common denominator. And that means I can do the operations on top, which is x squared minus 49. And if you remember, we try to factor and simplify this fraction. So if we look at this fraction on top, can I reduce x squared minus 49? Yes, I can, because it is a special factor. So that means x squared minus 49 becomes x minus 7, x plus 7 over x plus 7. Once you have factored, you look for things to cancel. And we notice that x plus 7 can cancel with x plus 7. And that means my result is x minus 7. Okay? So I have done the operation here, which is the subtraction, and my answer is x minus 7. And we love problems like this because the denominators is the same. Okay, so let's look at another example which will be similar, where the denominators are the same. So basically, let's say we have y cubed divided by 3y squared subtracted by 4y cubed divided by 3y squared. Okay, denominators are the same, so that means that we can write under the same denominator, which is 3y squared. And on the top, we can write y cubed minus 4y cubed. Alright, first thing we notice is that we can combine these y cubed minus 4y cubed. So what we're going to do is y cubed minus 4y cubed is negative 3y cubed divided by 3y squared. And let's see if we can cancel anybody. We notice that the 3 can cancel. And the y, because 3 is bigger than 2, the y will stay on top. It will be y to the first. And we still maintain the negative. So my answer for this problem is negative y. Okay, let's continue on with the lesson. And what we're going to do now is write a formal definition of least common denominator, which we're going to abbreviate with LCD. So LCD stands for least common denominator. In the definition of least common denominator, basically what it is a list of all unique factors to the highest power. Okay, so let's look into what that means. Okay, so we're going to do a few examples here where we're going to determine the LCD, the least common denominator, of different rationals. So here's example number 2, and suppose the example number 2 says find the LCD of the rational expressions below. Okay. Alright, so let's go on to problem letter A. And the problem letter A is going to be 7z over 12x to the fifth, y to the second, comma, 5w, 54 xy to the third. Okay, suppose I have these two rationals, okay, and I'm supposed to find the LCD. So how am I going to find that? Basically what you need to do is break the numbers into prime numbers, okay, or a product of prime numbers. Okay, you probably remember doing this before. It's called prime factorization. But before we can do this, I just need to do a quick review what prime numbers are. So prime numbers are numbers that can be divided by 1 and itself. So if I look at number 2, for example, number 2 is a prime number because the only numbers that go into 2 is 1 and the number 2. So 1 and the number itself. So 2 is a prime number. If I look, for example, at number 4, for example, number 4 would not be a prime number because 1, 2, and 4 go into 4. So to be a prime number, remember, only 1 and the number itself have to go into the number. But in this case, I have more than that, so this is not a prime number. So if you look at number 5, for example, 5 is a prime number because 1 and 5 go into 5. So this will be a prime number. If I look at number 17, for example, another prime number because the only numbers going to 17 is 1 and 17. So let's go ahead and make a list of prime numbers, at least a few of them. So starting with number 2, we're going to have 2, 3, 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19. 19 is a prime number. 20, 21, 22, 23 is a prime number. 24, 25, 26, 27, 28, 29 is a prime number. 30, 31 is a prime number. 33, 34, 35, 36, 37 is a prime number. 38, 39, 40, 41 is a prime number. 43, prime number. 44, 45, 46, 47, 49 is not a prime. 50, 51, 53. Alright, and the list goes on, but here we have a few prime numbers. Okay. Alright, now that we have talked about prime numbers, let's go back to our original problem here. And remember I said we need to break this 12 as a prime factorization, or a product of prime numbers. So what we're going to do, we're going to do the prime factorization, which is we're going to break this number 12 into into two numbers. Okay, so you ask yourself, what two numbers other than 1 that multiply will give you 12? So let's say I do 2 and 6. You could also have done 3 and 4. It doesn't matter. Once you break down the two numbers, you ask yourself, is this prime? Yes, it is. So you put a circle around it. Is number 6 prime? No, it's not. So what are you going to do? You're going to break down the number again. So this would be 2 times 3. Alright. Now that I factored that, let's go ahead and do number 54. What two numbers will give me 54? Well, 9 times 6. Are they prime? No, they're not. So continue breaking them down. 3 times 3 gives you 9. And 3 is prime. So put circles around. And 6 you can break down as 2 times 3, which are also prime. Now that I've done the prime factorization, what I'm going to do is write the two denominators right here. 2x to the fifth, y to the second, and I'm going to write the prime factorization next to it. So basically, if I look at the prime factorization of 12, I have a factor 2 How many 2's do I have? I have 2, so I raise it to the second. Then I look for the factor 3. I only have 1, so I put to the power 1. And then I also have variables, x to the 5th, y to the second. Now we're going to do the second denominator, which is 54. And that also have x and y. And now I'm going to line up my factors. In other words, I'm going to write in prime factorization. I have only 1 2. I have 3 3's. I have 1x. You can choose to put a 1 or you can leave it blank. And you have 3 y's. Now that we line up the factors, remember LCD is the list of all the unique factors raised to the highest power. So basically, when I look at these two, I have the factor 2, and I'm going to raise to the second power because that's the highest exponent between the two. The 3 would be 3 to the third, the x would be x to the 5th, and the y would be y to the third. So the highest exponent will be what you're going to use for the LCD. And that right there is your common denominator. You can leave it in factor form like that, or you can multiply it out. So 2 to the second is 4, 3 to the third is 27. Take a calculator here, multiply 4 times 27. 4 times 27 would be 108. X to the 5th, y to the third. Okay, so that will be the common denominator for these two rational expressions. Okay, let's go on to the next example. So let's do an example letter B. And let me bring some more paper here. So let me move up this example. And let's do example letter B. And this time I have two rational expressions, and I'm supposed to find the common denominator. Well, this is a little bit different than the previous problem, because the previous problem we're dealing with monomials. Remember, one term. Here I'm dealing with binomials. And first thing you need to ask is, can I factor this binomial? And by looking at it, we notice that this is a special factor that would change this into x minus 2, x plus 2. We look at this and we ask, can we factor? Well, first thing I notice is that the x is not in the front, so I'm going to switch them. So this would be negative 3x plus 6. Last thing I notice, I have a negative in front, so we don't like that. So let's go ahead and factor the negative. I also notice that I can factor out a 3. So that way this will become x minus 2. So basically, when I approach these, I factor the first denominator, I factor the second denominator. And now we're going to do the same thing we did before. Okay? And to save time, we don't have to copy the first denominator. We just have to write down the factor form of the first denominator. So my first denominator is going to be x minus 2, x plus 2. My second denominator, I'm going to line up my factors. Okay, if you notice, the first denominator didn't have any numbers in front. This one has a negative 3. And I also have an x minus 2. So I line up the x minus 2 with x minus 2. I do not have an x plus 2, and that's okay. We just have to line up the same factors, one on top of the other. Now remember, LCD is the list of all the factors to the highest power. Well, we do have a negative. We do have 3 to the first. Here, remember, there's an invisible 1 right there. So I do have this factor, x minus 2, and the highest exponent is 1. And then I have x plus 2 again. So my LCD for this problem right here is negative 3, x minus 2, and x plus 2. Alright, let's continue on to the next problem. So let me move on the paper here. And let's do letter C. Okay, letter C is going to be m minus 1 over m squared minus 25. And then I'm going to have n minus 1, 2m squared minus 9m minus 5. And the last one is going to be n minus 1, 2m squared minus 20m plus 50. Alright, so first of all, let's factor. We know that this is a special factor, so this would be m plus 5, m minus 5. This over here, I asked myself, can I factor anything from all three? No, I cannot. Can I use special factors? If I notice the first and the last, they're not perfect squares, so I cannot use special factors. So basically I have to do 2 times 5. Do here on the side here. 2 times 5 is 10. Which numbers give me 10? 1 and 10, 2 and 5. And I'm looking for something that gives me a 9. And I notice that 1 and 10 will give me a 9. Sign of the biggest will be the same sign as the middle term. So that means the 1 have to be all positive, because negative 10 plus 1 will give me a negative 9. Alright, so that means I copy the first term, 2m squared. I break down negative 9 as 1m minus 10m. And I bring down negative 5. Okay, now I'm going to group them in pairs. So this would be, I can factor out an m, so this would be 2m plus 1. And here I can factor out a negative 5, so this becomes 2m plus 1 as well. So what do they have in common? 2m plus 1 and m minus 5. So that means this is the factorization of the second denominator. So put a line right here. Okay, if I look at the last one here, I ask myself, can I factor anything from all three? And you bet I can factor out a 2. So that means this will become m squared minus 10m plus 25. Second question I should ask is, can I use special factors? And if you notice inside the parentheses, these are perfect squares. So let's do a little test here to see if I can use the special factor. Well, to fill in the blanks here, I need to do the square root of the first, which will become m, and do the square root of the last, which will become 5. And then I ask, 2 times m times 5 gives me a 10. Yes, it does. So that means this becomes 2m 5 squared, and the deciding factor, if it's a positive or negative, is right there. Because it's a negative, I put a negative. So there we go. We had 3 denominators. Here the factorization of all 3. So what I'm going to do now, I'm going to write all 3 denominators one after the other. So I'm going to line them up. Starting with the first. The first I have m plus 5 and minus 5. The second one, I have m minus 5, and I have a 2m plus 1. And the last one, I have a 2, and I have an m minus 5 to the second power. Now I'm ready to decide what my LCD is going to look like. Well, the LCD is the list of all the unique factors to the highest power. So I have factor 2, I have factor m plus 5, I have the factor m minus 5 to the second power, and I have factor 2m plus 1. So right there, I found my LCD, my least common denominator for these three rational expressions. Okay? Alright. Okay, now we're going to do example number 3, where we're going to apply what we learned about LCDs in order to add or subtract rational expressions. So let's suppose I have example number 3, which says perform the indicated operations. Very well. And let's say I have example letter A, which is 2 over 18 x squared y plus 5 15 xy to the third. Okay, so what I'm going to come here to the side of my paper, and I'm going to do the prime factorization of number 18, which happens to be 2 times 9, and we know that 2 is prime, so we put a circle around it, but the 9 is not prime, so we're going to split it as 3 times 3. We did the same thing with the other denominator, which is number 15. We want to split it, and what your numbers give me 15 is 3 and 5. Alright, very well. Now that I have that, what I'm going to do is I'm going to write the two denominators here. I'm going to line them up. So the first denominator is 18, so I'm going to write 2 to the first times 3 to the second and times x squared times y. Now I'm going to line up the second denominator, which happens to be 3. It has a 5, and it has, let me do this, let me erase this, and just move a little bit. So, I don't have a 5 on the top, so I have x squared times y, but on the bottom I have a 5, I have an x, and I have y to the third. Alright. So when I line them up, this is my first denominator, this is my second denominator, this would be my LCD, my least common denominator. I have a 2 to the first, I have 3 to the second, I have 5 to the first, I have x to the second, and y to the third. So basically, this is my LCD. Okay? So what I'm going to do now, once I have my LCD, put a little box around it because I want to always come back to this. Okay? I'm going to copy my first denominator, but I'm going to copy in its factor form. In other words, I'm going to use this as my denominator. Okay? That is my this is my denominator in factor form. So I'm going to copy the top as a 2. On the bottom, I'm going to put 2 times 3 to the second times x squared times y. That's what my denominator is right now. Okay, now that I have this denominator, what I'm going to do is I'm going to compare this denominator with the LCD. I want to make sure the denominator is the same as this. If you notice, the denominator right now has only 1, 2. The LCD only has 1, 2. So we're okay. This denominator has 3 to the second. The LCD also has 3 to the second. We're fine there. If you notice, this denominator does not have a 5. The LCD has a 5. So what we're going to do is we're going to multiply top and bottom by what's missing. We're missing a 5, so we're going to put the 5 right there. Okay? So here's my 5 right there. Alright. Now, going down the list, we have x squared, and the LCD has x squared. And this guy here has a y, and the LCD has 3 y's. So I'm missing 2 y's right here. So this would be y squared and y squared. Alright, so that's what I'm going to multiply this guy by. Alright, now I'm going to copy down the next denominator, which is 5. Remember, I'm going to copy in the factor form, so this would be 3 times 5 x y to the third. I'm going to multiply by what is missing. Okay, if you notice, we're missing a 2. When we compare this denominator with the LCD, we're missing a 2, so we multiply top and bottom by 2. This denominator only has one 3. I need to have 2 3s, so I'm going to multiply by another 3. I am okay with the 5s. I'm missing an x, so I'm going to multiply by x. And I'm okay with the y's, because I have y to the third and the LCD has y to the third. So basically, I copy the denominator in its factor form and I multiply by what is missing when I compare it with the LCD. The reason why I can do this is, what is 5y squared divided by 5y squared? Basically, 5y squared divided by 5y squared equals 1. So basically what I'm doing here, I'm taking this first denominator and I'm multiplying by 1. Now remember, if I multiply by 1, I don't change anything. And that's the reason behind of why I can do this. Now the advantage of doing this is by multiplying by what's missing, I'm making sure that both denominators are the same. And once the denominators are the same, I can do the operations on top. Because remember, to add or subtract fractions, your denominator has to be the same. So I cannot do 2 plus 5 equals 7 because the denominators are not the same. Now that my denominators are the same, I can do the addition. But before I can add, order of operation tells us to do the multiplication first. So I'm going to have to do the multiplication here and the multiplication there. So let's go back here. Now that we have a common denominator, I'm going to write over here on the bottom. And once you write it here, you can go ahead and multiply this out. So this would be 2 to the third. 2 times 3 to the second. 3 to the second is 9. So 2 times 9 is 18. 18 times 5 is 90. So we have 90 x squared y3. If you got lost here, well, how did I get the 9? Basically, I just punch it in. 2 times 3 times 3 times 5 in the calculator. The calculator gave me 90. Okay? Alright. Now I'm going to do the multiplication on top. 2 times 5 is 10y squared. And here it would be 5 times 2 times 3 would be 30x. Now that I have them, I'm going to look on the top here and can I factor anything? And I notice that I can factor out a 10. So let's go ahead and factor out a 10. So this would be 10y squared plus 30x. Sorry, not 30x. 3x. Right, because 30 divided by 10 is 3. And here on the bottom I'm going to have 90 x squared y to the third. Now when I compare these two, I can cancel the zeros. So this becomes, or I can cancel the 10s. 10 goes into 10 one time, 10 goes into 90 9 times. So basically this would be y squared plus 3x on top. And on the bottom I'm going to have 9x squared y to the third. And there's nothing else I can do with these two. So I'm done. Alright, very well. Letter B. Okay. Letter B is going to be a similar problem. In fact, if you like to try it out before seeing the answer, you can. There'll be like a practice problem. Or you can just watch the video as we go through it. Okay, basically, again, we're going to take the denominator and we're going to do the prime factorization. So prime factorization of 15 is 3 and 5. And then we're going to do the same thing with 25. Prime factorization of 25 is 5 and 5. And since both are primes, you put a circle around it. Okay, now let's do find the common denominator. So the first denominator will be 3 to the first times 5 to the first. We have p to the third and q to the first. On the second denominator, I have 5 to the second, p to the fourth, q to the first. My LCD is 3, 5 to the second, p to the fourth, q to the first. Basically, I'm copying all the factors and using the highest exponent. Okay, so this is my LCD. This is what I want my fractions to have on the bottom. Okay, this is the same as 3 times 5 to the second is 75, p to the fourth, q to the first. We're going to use this information later. Right now, we're going to focus on this one. Okay, basically what you're going to do, you're going to copy the first denominator in its factor form, basically using these numbers right here. So 3 times 5 times p to the third times q to the first. And then you compare this with your LCD and what is missing. Well, I can see that I'm missing a 5. I'm also missing 1p. And the rest I'm okay. Then I copy the second denominator in its factor form. So this would be 5 to the second, p to the fourth, q to the first. Alright, and then we check what we're missing. Well, we're missing a 3 on a 3. We're okay with the 5s, we're okay with the p's, we're okay with the q's. So there we go. Now that I have made sure that both denominators are the same, and yes, they might not look the same, but if you pay attention to the different factors, they both have 3's, they both have 2 5's, they both have 4 p's, and they both have q's. So it doesn't matter the order, as long as they each one have the same number of factors, we're okay. We have a common denominator. Now that we have a common denominator, we can use that number right there, which is basically is 3 times 5 to the second power is 75. Very good. Now we're going to do the addition before we can do we're going to do the multiplication before we can do the addition. So 4 times 5 is 20p, and 3 times 3 is 9. And we ask ourselves, can I factor anything from these two terms? The answer is no. So that means that our answer stays like this, because there's nothing else that I can factor, and because I cannot factor anything, there's nothing I can cancel. So that would be my final answer right there. Okay. Alright, let's go on to the next problem. Problem letter C. Okay, remember, if you always can stop the video to take a second look at the problems, to copy your notes. Okay, you can replay. That's the advantage of the website, and I hope that will help you. Okay, letter C. This would be 2x minus 6 over x minus 1 minus 4 1 minus x. Alright, for this one, we have binomials, and what we want to do is make sure we factor them as much as we can. When I look at this guy here, there's nothing I can factor, so basically just write it down, x minus 1. Okay, now when I look at the second one, I notice that I can flip them because I want the x on the front, so this becomes negative x plus 1. And again, I don't like the negative in front, so I'm going to factor in a negative. So negative x divided by negative is a positive. A positive 1 divided by a negative is a negative 1. So my second denominator is negative 1, or negative. Okay, because remember this is a 1 right there. And I also have an x minus 1. So my LCD for these two denominators will be negative 1 and x minus 1. So this is what my LCD should look like. Now that I have that in mind, I'm going to bring down my first denominator, which is 2x minus 6 over x minus 1. and I compare my denominator with my LCD, and I notice that I'm missing something. I'm missing a -1. So I'm going to multiply top and bottom by a -1. And I'm going to do the same thing with the second term here. I'm going to bring it down the fraction, and I notice that I have -1 x minus 1. Right, remember there's an invisible one right there. Alright, when I compare this denominator with the LCD, they're the same. So that means I don't have to multiply by anything. This one is okay. This one here was missing a -1. That's why I multiply by -1. Now they have a common denominator. I write one denominator, and I can go ahead and apply the multiplication. Remember, there's a parenthesis here, so you're going to use distributive property here. So this would be -2x plus 6 -4. Okay, notice here that we can combine like terms. 6 and 4 becomes -2x plus 2 over -1 x minus 1. We also can ask ourselves, can we factor anything here? And you bet, we can factor out a -2. So that means this becomes x minus 1. And here, on the bottom, I have -1 x minus 1. And would you look at them? I can cancel the x minus 1. I can cancel the negatives. And 2 divided by 1 is 2. So who would have thought that this subtraction would come down to become just number 2? Pretty cool, huh? Alright, let's go on to letter D. Alright. Letter D will be 5x over x squared minus 4 minus 2 x squared plus x minus 2. First order of business is to factor the denominator. Can I factor this? And this should ring a bell. This is a special factor. X plus 2, x minus 2. This one here, we cannot factor anything from all three. We cannot use special factors, so that means we have to do 1 times 2. 1 times 2 is 2. Numbers give me 2, 1 and 2. With 1 and 2 give me a 1, you bet. The 2 have to be positive, the 1 would have to be a negative. So this would be x squared minus 1x plus 2x minus 2. We're going to factor from the first 2 and from the last 2. What can I factor from the first 2? An x, so this would be x minus 1. And what can I factor from the last 2? I can factor out a 2, x minus 1. So what do they have in common? They have in common x minus 1 and x plus 2. So that means all I did so far is to factor both denominators. Okay, and I came up with this. Let's not line up. First denominator will be x plus 2, x minus 2. Second denominator is going to be, I don't have x minus 1. I'm going to line up over here. And x plus 2, I'm going to line up right here. Alright. Now, the LCD. The LCD will be x plus 2, x minus 2, x minus 1. With that now, this is my LCD. Okay, so now what I'm going to do, once I have my LCD, is to copy the first denominator, or the first term, first fraction, but in its factor form. So x plus 2, x minus 2. Now I need to look, what am I missing? If I compare the 2, I'm missing an x minus 1. So that's what I'm going to multiply top and bottom by, is an x minus 1. Then I'm going to copy the second fraction in its factor form. compare that with the LCD and find out what is missing. We notice that we're missing an x minus 2. So what we accomplish here is we found the common denominator. We make sure that both rationals have the common denominator. So basically what I can do is write one common denominator, which is x plus 2, x minus 2, x minus 1. And now that I have common denominators, I can do the multiplication and then do the subtraction. So I'm going to do this. So 5x times x is 5x squared. 5x times negative 1 is negative 5x. Gotta be careful here. This negative goes with the 2. So you multiply negative 2 times x, negative 2 times negative 2. Very, very careful with that negative there. Okay? So this would be negative 2x, positive 4. Alright. Combine the terms. So this would be 5x squared minus 7x plus 4. And on the bottom I have x plus 2, x minus 2, x minus 1. Now, we're almost done. We just need to check if we can factor the top, because maybe we can factor the top and cancel somebody out. So let's go through the three questions that we need to ask. Question number 1, can I factor anything from all three terms? And the answer is no. There's no number goes into 5, 7, and 4. Second question, can I use special factors? This is a trinomial, so maybe I can use the first one, but to be able to use the first special factor, these have to be perfect squares, which one? This one is, but this one is not a perfect square, so special factors out of the picture. Question number 3 is, if not a special factor, then multiply 5 times 4 and see if it works. So 5 times 4 is 20. Write down the numbers that give me 20. Well, 1 and 20, 2 and 10, 3 does not go into 20, 4 does go into 24 times 5, and that will be it. Now we're looking for any pair here that when added or subtracted give me a 7. And the thing is, nobody here will give me a 7. So that means I cannot factor this. So that means this stays like this. This is my simplest form. Okay? So that is the answer for this problem. Alright, so now we're ready to go on to the next example, which is letter E. Just give me a second here to bring out the paper. Alright, here we go. So we're going to do letter E. And letter E is going to be 2x minus 1 over 4x squared minus 20x plus 25 plus 3x over 4x minus 25. And the question is, add these two fractions and see what you get. Okay, first thing I need to do is factor the first denominator. And can I factor anything from all three terms? And the answer is no. Can I use special factors? Well, if I notice these two guys are perfect squares, so that means I can just have to do the little test, which is 2 times the square root of the first times the square root of the second. Square root of the last. So square root of the first will be 2x. Square root of the last would be 5. And the test is, when I multiply these three numbers, does that give me a 20? And the answer is yes. So that means the factorization of this is 2x and 5. Basically, I put this number here, this number there. Because I have a minus there, this would be minus, and be to the second power. So that was pretty cool. This one should ring a bell. They are perfect squares. They only have two terms. So that means there's a special factor that says, take the square root of this would be 2x. Square root of that, this would be plus 5. And then copy it again, 2x. but this time put a minus. And that's the prime factorization of that. Okay? Alright, now that we have that, I'm going to come over here and I'm going to line up our factors. The first denominator is 2x minus 5 to the second power. We're going to line up the second denominator, which is, it does have a 2x minus 5. It also have a 2x plus 5 that I need to write on the side. So the LCD then here would be 2x minus 5 to the second power, because you need to use the highest exponent, and 2x plus 5. Alright, with that in mind, I'm going to put this in a box right here, that way we don't forget. I'm going to copy our first fraction, which is 2x minus 1 over 2x minus 5 to the second power. And I'm going to compare this denominator with the LCD. And we ask, what is missing? Well, the thing that is missing is the 2x plus 5. So that means we're going to multiply by 2x plus 5, top and bottom. I'm going to copy the rest, which is plus 3x over 2x plus 5, 2x minus 5. And we're going to compare that with the LCD, and we notice that we're missing 2x minus 5. So let's multiply it by what is missing. Because if you notice, you need to have 2. We only have 1 here. Alright, now to make sure that the denominators are going to be the same. So I can write under one common denominator, which is 2x minus 5 to the second power, times 2x plus 5. There we go. Now that I have a common denominator, I can do the operations on top. In order of operation tells us to multiply before we can add. And I'm going to erase this arrow right here, because this is a binomial times a binomial. So that means I'm going to apply FOIL. If you remember FOIL, F stands for first times first, is 4x squared. Then the O stands for the outside number, so 2x times 5 is positive 10x. You put on the outer box. The I stands for inner numbers. I times 2x becomes negative 2x, and you put the answer on in the inner box. Now that I have these two numbers, I combine them, so 10 minus 2 becomes 8x. And the L stands for less times less, so negative 1 times 5 is negative 5. Remember, the plus goes with the 3, and you're going to use distributive property in this case. Here you do FOIL because you have a binomial times a binomial. Here you're going to use distributive property because you have a monomial times a binomial. 3x times 2x becomes positive 6x squared. And 3x times negative 5 becomes negative 15x. Alright, now let's see if we can combine anything on top. We can combine the 4x squared and the 6x squared. So that means this will become 10x squared. Then we can also combine, so we're done with that. We can combine 8x minus 15, which will give you 7x. And we're going to combine negative 5. Well, so we're done with that. And the only thing we have left is the negative 5, so we're just going to bring it down. And copy the denominator. And now maybe we can factor this guy on top, and maybe something will cancel on the bottom. So let's take a look if we can. We need to ask those three questions. 1, can I factor anything from all three terms? And when you look at that, we cannot factor anything from all three terms. It's alright. Number 2, can I use special factors? Well, this is a trinomial, so the only possibility would be the special factor number 1. But the thing is, you need to have perfect squares, and we don't. So special factors out of the picture. So the last question is, can we factor by multiplying the first times the last? So let's see. 10 times 5 is 50. What numbers give me 50? 1 and 50. 2, and 25. 3 does not go, 4 does not go, 5 and 10. 6, 7, 8, 9, 10's already there, so we're done. Does anybody here give me a 7? The answer is no. So that means the top one cannot be factored. So that means nothing can be canceled. So we're done. This is our final answer. Alright. So now we're ready for our final and last example. Okay, it will be letter F. And this will be 7x minus 1 plus 10x x squared minus 1 minus 5 x plus 1. Alright, so first of all, factor. Can I factor this guy? Nope. So let's just write over here x minus 1. Can we factor this guy? You bet. This is a special factor, x plus 1, x minus 1. So let's line it up. We have an x minus 1, and we have an x plus 1. Third denominator. There's nothing I can do to factor, so this is the only thing I can do. Alright, now that I factored and lined up all my factors here, I'm going to find my LCD, which is x minus 1, x plus 1. Alright, now with this in mind, I am going to copy each of the fraction in its factor form. I'm going to compare this with the LCD and ask myself, what am I missing? I'm missing x plus 1 over x plus 1. Copy the second one. This would be 10x over x plus 1, x minus 1. Compare that with the LCD, and I notice I'm not missing anything. That's great. That means I don't have to multiply by anything. Just move on to the next one. 5 x plus 1. What am I missing? I'm missing x minus 1. Alright, very well. Now that I have them, what I've accomplished is I have the same denominator, which is x minus 1, x plus 1. Now with that, that means I can do the operations on top, starting with multiplication. So 7, let's use distributive property. So this becomes 7x plus 7. I'm not doing anything with the middle here, so I'm just going to bring it down. And this has a negative 5, so please make sure you multiply by each one. So this would be negative 5x plus 5. Alright, now let's combine like terms. I can combine 7x, 10x, and negative 5. So if I combine that, I am going to get 12x. I'm done with that. Then I'm going to do 7 and 5. 7 plus 5 is 12. Alright, now I notice that they both have 12, so that means I can factor out 12 here. So this would be 12 x plus 1. And when you look at that, I think we'll be able to cancel somebody here. And we'll be able to cancel the x plus 1. So that means my answer is 12 over x minus 1. Very well. So this concludes the lesson on add and subtract rational expressions. So now you're ready to tackle your assignment. Thank you very much for your time, and have a wonderful day.